Hi, I'm Teschler, Executive Editor of Design World magazine.
And I'm DiFrangia, Assistant Editor of Design World magazine. We are tearing down LED bulbs that are made to be equivalent to 60-watt incandescent bulbs. Today we are looking at an LED bulb called the E27 A19 from Home Ever Inc. in Las Vegas, Nevada. And I have to say, compared to some of the other bulbs you've seen, the mechanics of the Home Ever bulb and its electronics look pretty simple.
I agree. This particular bulb seems to have been imported from China, and on imported products like this, it's always interesting to try and figure out what operations were done by hand and what were done by machine. In that regard, we can see the two-sided circuit board in the bulb seems to have been reflow soldered. In other words, it went through an automated reflow soldering machine. Two wires connect the board to a metal plate holding 30 LEDs. Two more wires go to the light socket conductors. But judging by the globs of solder we see here, all four of these wires look as though they were hand soldered. The bulb is built around a 2-inch high heatsink that weighs 2 ounces and looks to be a metal casting. The base of the lamp contains a plastic housing that holds the AC-DC converter. The electrical connections to the lamp socket are at one end of the housing. The other end attaches to the heatsink with 2 small screws.
At least one of the LED bulbs we've looked at have the LEDs attached to the circuit board, but this one has them attached to a separate metal plate.
Right. The 2-inch diameter metal plate containing the LEDs attaches to the heatsink along with a frosted polycarbonate bulb. The plastic bulb apparently snap fits into the heatsink while the LED plate attaches with 3 screws. There's a couple of spots of compound for thermal conduction applied between the LED plate and the heatsink. That brings us to the AC-DC converter design, which appears to be pretty straightforward. The only components on the board that aren't surface mounted are 2 big capacitors, a surge resistor on the input, and a transformer. Connections from the board to the screw base and to the LED board are through discrete wires, but the connection to the bulb foot contact was done by a machine. The electrical connection to the metal screw threads, though, is simply a length of bare wire squeezed between the plastic housing and the inside surface of the screw threads. The electronics on the AC-DC converter are bare bones. The diode bridge on the input is 4 discrete diodes rather than a bridge chip. There's a single IC in the board. It's a buck topology supply, and it's made by Bright Power Semiconductor in China. According to the spec sheet, the chip, dubbed the BP2812, incorporates a 600-volt MOSFET. The spec sheet also lists the chip operating current at 200 microamps. Like most suppliers of driver chips for LEDs, Bright Power publishes a reference application circuit for its device, and this typical application circuit listed on the BP2812 spec sheet comes extremely close to the actual circuit we found on the LED circuit board. 7 resistors go into simple networks that handle the V sub CC voltage, sensing the buck inductor's peak current and regulating the input voltage to the IC. 5 capacitors handle chores of AC line filtering and AC bypass for the V sub CC pin and line sense pins and the buck topology. An inline fuse cuts the power to the whole circuit in the event of a too high current draw.
We also found something interesting on the website of Bright Power, the Chinese company that makes the driver chip. It looks as though Bright Power may have assembled the circuit board itself. Images on its website show example circuit boards for a few other LED applications that look remarkably similar to what we see in this bulb.
Right. We'll finish up by commenting on a couple other aspects of the bulb's operation. First, it doesn't seem to factor in temperature effects. LEDs put out less light as their temperature rises. That's generally not a problem for small temperature changes. The eye's sensitivity to light is logarithmic, and the eye is not particularly sensitive to small changes in luminosity. It's not unusual to see a 10% drop in LED lumen output as junction temperature rises from room temperature to 150 degrees C. But LED current can also be reduced at higher temperatures as a way of lessening the need for heat sinking. That said, there's no temperature sensing that we could see in the Home Ever bulb's AC-DC converter. And finally, there's no circuitry for dimming. But all in all, the LED bulb probably works well enough in uses that don't need a dimmable light.
Yes, and the LED bulb still puts out as much light as a 60-watt incandescent bulb. And if you want to brighten up your life with more videos like this one, check them out at designworldonline.com.